Hello, so welcome to this video again, and this time we are going to talk about a special type of sensor called as pressure sensor. So as the name suggests, it is called as pressure sensor because it detects or senses a pressure and converts that physical quantity into proportionate electric signal, for example a voltage. So now the question is, if it is a pressure sensor, what kind of pressure it detects? So the pressure may be an atmospheric pressure, for example the surrounding air that we live in, or a pressure of a gas filled in a chamber, or pressure of a liquid filled in a tank. And there are so many applications of the pressure sensor in industry, in medical field, in avionics, and so many other things. So the picture shows the very conventional type of pressure gauge. It is also called as manometer, pressure manometer, or pressure barometer, which is a manual pressure gauge. It is called as manual because there is a needle as shown over here in the circular disc encompassing this sensor unit, and the pressure of a gas, or for example an air, goes inside, and based on that this meter displays the quantity of that pressure. So as you can see, there are two units to measure the pressure. One is the red scale that starts from 0 psi up to 35,000 psi, and second unit of measuring the pressure is from 0, the black scale, and it goes up to 2.5 kilobar. So this is the range of a pressure that this unit can be used to measure. There are in the market these manual pressure gauges which are used in industry, for example in a agriculture industry or in a manufacturing industry, where there is a gas pipe and one wants to measure the pressure of a gas inside the pipe. So there these meters can be equipped or installed. Okay, so in a modern day technology we have this digital type of pressure sensor. So they are called as digital pressure sensor. So what it does is that, you see now, this is like two small inlets available. Here is a one small inlet where the pressure of an air can go inside, or pressure of a gas. So remember, the pressure of air has a certain value, and the pressure of a gas, for example oxygen, nitrogen, or any other gas for that matter, they have a different value, and we want to measure that value per cubic volume. For example per meter cube, we can say that the value of the pressure of a gas that will go inside this pressure sensor through these inlets. So there are two valves here, two inlets here, that is going to measure a differential pressure. This is differential pressure. This is used to measure differential pressure. So one inlet is for a reference pressure, for example pressure of an surrounding air or atmospheric air, and the second inlet is to measure the pressure of a gas, for example oxygen, nitrogen, or any other gas that we want to measure. In the case of singular inlet, you just let the gas which you want to measure pressure of go inside this, and accordingly you make your measurements. So now you see these sensors comes in the form of integrated circuits, where these are the pins, and this is the back side of the sensor, which is sealed, and inside when the pressure gas goes in this sensor box, with the principle of measuring that pressure. For example, there may be a diaphragm, a very thin diaphragm, that gets deflected with the air going inside this sensor, and then that deflection of the diaphragm can be sensed by means of change in the capacitance, for example, or change in the resistance, etc., or maybe even the piezoelectric property can be used, where the air going inside the sensor can squeeze or expand the piezoelectric diaphragm, and then the charges will be generated due to piezoelectricity effect. Accordingly, whether it's a change in capacitance, change in resistance, or change in the electricity or generation of electricity, that is piezoelectric effect, this sensor inside converts that into proportional electric voltage. Then there is a to D converter, which takes the input analog signal to proportionate digital codes, and then there may be a microprocessor or microcontroller inside the sensor. So all integrated together, you see, in a small piece of this sensor, which is about, let's say, 2 centimeter wide and 2 centimeter long, and maybe the height is about 1 centimeter or even less. So this is the volume of the sensor that you come across. Okay, so we just understood what the sensor is, how it works, and these are the modern day sensors, which are called as digital pressure transducers. Okay, so here I am showing you a small PCB, or called as breakout board, where you see this small piece of sensor that is installed on this small PCB, and here is the hole or inlet where the pressure of intended gas goes in, for example our surrounding air, or maybe a gas in a pipe, or for example some other air gas. And then there is surrounding electronic components. For example, there are capacitors right here, and there are resistors, the black one with the printed code, and there are some other components, maybe voltage regulators or etc. So you need to know what these components are and what the specification of this pressure sensor. Then you just have to visit the data sheet of the manufacturer. I'll tell you in a moment how. And then you see these are the through hole connections to make the connections of this breakout board with the external PCB or some other electronic designs, and that's how you can do that. So here is the input V in, there is a ground, there is a 3 volt output. So this pressure sensor gives you an output voltage according to, so input is the pin where you give a power to the PCB to turn on the pressure sensor, and the output you take from the sensor with respect to ground. And then there are some other pins like reset or SD, etc. So you can refer information from the data sheet. So let me take you to another kind of pressure transducer, or it is also called as force. It is used to sense the force. So remember, force F is equal to your or we say that the pressure is your force upon area per unit area. So the force would be pressure multiplied by the area. Okay, so P times A. So this is also called as force transducer or pressure transducer. So what you see here is the resistive area basically, and this is a kind of circular sheet, and there are two connections. So it's basically measures the change in resistance when you bend or move this piece of circular transducer. So when you bend it, it experiences the change in resistance, because this is the resistive material, actually the piezoresistive for example, or simply a resistive, which exhibits the change in resistance delta R over R when you bend it, and that change in resistance is sensed across these two terminal, and this is simply a resistor, a variable resistor, where the bending changes its resistance. So with this simple R, you can put it inside a Weston bridge or simply a potential divider. For example, this is your sensor, uh, RS, and this is your nominal resistance. You ground it and you have this, let's say, voltage supply V plus, and you have the output here. So when there is a change in resistance here, your voltage output will change, and that's how you convert the input pressure or force into output voltage. Okay, so that was about your pressure sensor. This is also called as flexible pressure sensor. Okay, so bringing back to our discussion, this is a modern day pressure transducer. Again, you see that this is a fully packaged, this is the fully packaged pressure transducer. Inside there's a small hole where the air or a gas or pressure of which you want to measure can go in, and then the pressure transducer works like that. Here these are the capacitor, these are the resistors, these are the resistors again. Here is some other component, here is again some component, maybe a voltage regulator. So how to know what those pins are and how to understand their interconnection? So the suggestion would be to refer to the data sheet. So for example, this is BMP085 pressure sensor. So just Google with this name and manufacturer will give you the data sheet of this sensor. Okay, so for example, it gives you 3-volt output. This is the V in, as the arrow direction indicates. This is the input, this is the input to the sensor, this is the output from the sensor. Okay, this is ground, and some other pins, know what their functions are. Since I told you this is a digital transducer, so there are so many ICs, integrated circuits inside, and integrated within this square box, which is a transducer. Okay, so another type of breakout board, you see that there is already a connection, connectors provided here to connect it on a breadboard or with the Arduino or microcontroller, and you see the name of this is BMP180. So here is that pressure transducer, and here is that small hole or inlet where the air can go inside or gas can go inside. Here is a capacitor, these are the terminal, input output terminal, positive, negative. So you just type this number on the Google and get the data sheet and know what this sensor specifications are. So here I am bringing to your attention another type of digital pressure transducer. Again, here is the embedded sensor. Here is the inlet where the air can, a small hole where the air can go in. These are the two small capacitors. This is the VDD, that is the power supply to the breakout board with respect to ground, and there are some other pins. You can see their functionality by referring to the datasheet of this component. So hope you like this video. We understood in this video what the pressure transducer is or pressure sensor is, how it works, what are its uses, where it is used, in what industries it is used. And I also explained you the inside of this pressure transducer. There is a sensor and there are ASICs, application specific integrated circuit. For example, when your pressure is converted to an electrical voltage inside this piece of sensor, there is also circuits, electronic circuit, that processes that signal to, for example, A to D converter and so on. And that's why you are getting the outputs in digital form or analog form depending on what pressure sensor is there. So do share this video with others, like and subscribe to the channel, and wish you happy learning. Hope you like this video.